Hello and welcome to Beginners Python and Machine Learning. My name's Tim Cummings. Every Tuesday we give a presentation on how to use Python, and we also delve into machine learning. I won't be doing machine learning myself today. That's normally handled by Arun, but the focus of today is for absolute beginners, for people who've never seen Python before. So we do that on the first Tuesday of every month, and the way we do that is we use Google Colab. Google Colab provides an excellent Python environment. You don't even need to have Python installed on your computer. You just log into Google Colab, and you'll need your own Google account, and from there Google will give you basically a Linux computer running Python. And it'll be interactive Python using Jupyter notebooks. So let's get started. I'm on the meetup page here at the moment, but even if you're just on the YouTube video page, you'll find in the summary below a link to colab.researchgoogle.com, and this link here will take us to the shared notebook that we will be using today. So click on that link and bring up the notebook. Now the idea of today is for absolute beginners, so any question is a relevant question, and I'll be listening in Slack, and I'll also be watching the YouTube chat, so you can ask questions on either of those, and I'll endeavour to answer them. So I'll be watching YouTube chat, and I'll be watching Slack in the Learning to Code channel. Alright, so this is Google Colab. This is a notebook that I prepared earlier for Meetup 132. For beginners, we're going to look at variables and data types. Now the first thing you want to do is copy that to your drive so that you can start making changes to it and save them in your own Google Drive. So you can either click on copy to drive, that big button here, or go into the file menu and say save a copy in drive. Both of those will do the same thing. So I'll click on copy to drive, and that'll open another window, and the name of this notebook will be slightly different. It'll now be copy of Meetup 132. So this is one that you can make as many changes to as you like. It won't affect the master one that everyone else is copying. Now I'll be making changes to it as I work through tonight, so I'll even share this one with you. So if you want, you can open this copy and just refresh it during the session, and you'll get all the typing that I've done, so you don't have to type everything yourself. So I'll copy that and I'll paste that to Slack, and I'll paste it to YouTube chat. Alright, so I look forward to questions, so please send them in. Alright, so challenge 1, get Python running. So this is where we're going to be, colab.research.google.com, and that'll give you Python 3.7.12. Alternatively, you can install Python 3.10.2 from python.org, and I like using PyCharm. PyCharm Community Edition is a free version of PyCharm. You can get that from JetBrains, and that's an integrated development environment, and that's easier when you're writing programs. But for learning Python, interactive Python is a bit easier because you get the results directly, and you can type in things and see exactly how it reacts. So that's what we're going to be using tonight, which is Google Colab, which is based on Jupyter Notebooks, which is based on IPython being interactive Python. So Google Colab, these Jupyter Notebooks, you'll see that it's made up of cells. Each cell you see has got a rectangle around it. This is a cell up here, and The cells can be either text cells or code cells. And at any point you can add another text cell or add another code cell, or you can even convert a code cell into a text cell or a text cell into a code cell. There's a whole bunch of keyboard shortcuts to help you. So look in the menu to look at the keyboard shortcuts, and you can see what they are. You can even customize them if you want, but I'll just tell you the ones that I use as I go through. Alright, this one was a text cell. This one's another text cell. You can see the text cells, they've just got headings and text and different formatting. The code cells, on the other hand, are all in the same font. There'll be comments are marked in green, which don't do anything, and you'll see that they're code that starts with the hash sign. So anytime you start a line with a hash, you can just write in anything you like to describe what you're working on. They start with a hash, and I'm going to show you how to find help in IPython, and that's by using the question mark. So we've typed a question mark here, it's in a code cell. Now we need to run that code cell. So we click on the play button here, run cell. Now the very first cell you run in a Google Colab notebook, you'll see up here it's connecting. So Google's setting up a Python computer for you, giving you a bit of RAM, a bit of disk space. There you go, RAM and disk space, so that you can start using Python. I've typed the question mark here, so it's brought up this help over on the right, talking about IPython and enhanced interactive Python. So you can read all about that. I'm just going to hide it for now and describe things as I go along. Google Colab also gives you a place to store files, so you can put files up here, or you can even access your Google Drive. But we won't be needing to do that tonight. We'll just do everything here. Alright. Okay, so let's get started. We'll talk about variables in Python. So variables are memory locations. Whenever you've got some data, you want to save it somewhere, and you also want to label that location where you've saved it so that you can refer to it later. And those locations as labels are called variables, because they're places where you can put data, and you can put different bits of data in there, which can vary, so they're variables. The names can be just about anything you like. You can't include any special characters other than letters of the alphabet. Numbers, you can't start with a number, but you can have numbers after the first letter. And you can put underscores in there, and that's what an underscore is. So here I've created a memory location. I've called it A, and I've put a value in it, calling it 3. So if I run this cell, and you'll see I've run it because it's got the tick beside it, and also it's now got the number 2 to say it's the second cell I've run. And now we've stored the value 3 in memory location A. So how do we see what's in A? We can use this print function from Python. So that's what's going wrong. My hand on the keyboard right, and I'm going to press Shift Enter. Does the same as pressing the play button there. I can do Control Enter, as you see it says there, and that'll leave me in the same cell, or Shift Enter will jump me to the next cell after I've done this one. There we go. So print A displays what the contents of A is. So these two lines here, they'll work in normal Python and IPython. IPython gives you another way of looking at the value of a variable. You can just put the variable name here, in which case A, and it'll come up with a 3. Alright, so I hope you've managed to run these cells and seen these same results happening on your screen that I'm showing you in the video. If that's not happening correctly, let me know, and we'll see if we can work through the issues. All right. Now we can work out, we can evaluate expressions in IPython. so we can just type in the expression. So for example, a plus 4, it'll look at the value in a, which is 3, and look at Google Collab. So clever, I can just hover over it and it tells me that's a 3 in there, and add 4 to that, and then when I run that cell, it works out that the answer is 7 and displays that result. So here's another more complicated one, a plus 15. I'll use some parentheses to say that I want to run that first, and then divide by 4 and calculate b, and the answer is 4.5. Okay, so what the way you learn Python is to actually do things. So now is a chance for you. Challenge 2, add 123 to 456 and display the result. Alright, so I've left a spare cell for you there. You can either pause the video at this stage and have a go at it yourself, and then play the video maybe a bit faster so you can catch up with the rest of us, or you might know the answer straight away. It's pretty easy. All we have to do is type in 1, 2, 3 plus 4, 5, 6 and press Shift Enter, and the answer comes up as 579. Okay, now I'll also provide the solution here, and it's doing it the way we would have to do this if we were using Python. We'd have to use the print function. So there we go. Solution 2 works in IPython, and there's the answer, 579. So you can see I've used the print statement to do two things. It's printed out this text, which I've enclosed in double quotes, and it's printed out, it's evaluated this expression here, and then it's used the print function to display the result. Now, one of the things you can't do with your variables is name them after a keyword. So what are the Python keywords? Well, fortunately, they give us a little library that will tell us what the keywords are, so we can make sure we don't use any of those keywords in our variable names. So to use one of the standard libraries, you just import the library. So I'm going to import keyword. I'm also going to import sys, SYS, so we can see what version of Python we are running. This is got a couple of advanced things in here, but I really just wanted to show you the list of keywords. So you can see false, none, true, and, as, assert, async, await, break, class, and so on. So none of those words you can use. If you try to do that, you'll come up with an error in Python if you try to use them as a variable name. There's 35 of them in Python 3.7.12. So that's what Google Colab is giving us. You'll see the ones with capital letters have come up first, followed by all the ones with lowercase, starting lowercase characters. All right, so let's just have a look at a couple of these. None is a keyword, and it's a value you give to a variable if you don't want it to have a value. So for example, if I've got a variable called n and I say n equals none, that defines the variable n but puts nothing in there. So if I say what's in n, there's nothing's showing at all. So if I didn't put n equals none, n would be undefined and I would get an error if I said tell me what's in n. Alright, another keyword is pass. Pass, I'm starting with the easy ones here. Pass is the keyword which does nothing. You'll sometimes need it in Python. You don't need it in other languages, but because Python uses indenting for defining code blocks, and we'll get onto that later, you sometimes need to use a pass. And so you can see if I run pass, it does nothing. Alright, now variable names can be as long as you like, and if you want to make them with multiple words in the variable name, the convention in Python is to put it all in lowercase and separate with the words with underscores, and that makes it very easy to read. So a long variable name equals 345, and there's our answer, 345. So anytime you like in your code block, you can add extra codes, code cells or extra text cells, and mainly code cells, and try some of these things if you want to. So for example, you could say a long variable, and it's even going to give me type completion divided by 2, 172.5. All right. So that's variables. Let's have a look at some data types. There's a function, a built-in function in Python called type that will let you see what data type a value has. So you can put either a variable name in the parentheses there when calling type, or you can put a literal constant like 456. So let's see what the type of A is. Remember, we stored the number 3 in there, and that's an int. So that's Python says int for integer. All right, I see we've got a comment here from Bixby, snake case, which is lowercase with underscore, and I guess that's right. Camel case is what Java uses, where they have capital letters on the following words, and the first word starts with a lowercase letter. You've got title case if you start with the first word with a capital letter as well. There's one called, I think it's called skewer case or shish kebab case or something like that, where you use hyphens to separate the words, and it's like a skewer all the way through it. All right, so remember B before, we did a sum with B. That was A plus 15 over 4, and the answer was 4.5. So what type is 4.5? Let's have a look. And it's a float. You see how also these code cells we're running down here are remembering the variables that we've set up higher. All right, so a floating point number has a mantissa and an exponent. It makes it possible to store very large and very small numbers in a small amount of memory. And the reason they're called floating point is because the decimal point floats through the number depending on the value of the exponent. So if I've got this number here, which is a very big number, because it can't show it all in the right number of decimal places, Python has a limit. It decides to show it in exponential notation, which is 1.23 times 10 to the power 19. So that exponent here tells you where to put the decimal place. So because it's got a 19 there, it says move the decimal place 19 points to the places to the right. Look at a similar number. It comes out to be exactly the same mantissa, and its exponent is minus 14. So that decimal point there goes 14 places to the left to get the original number that's being stored, and this sort of scientific notation helps you write down a very wide range of numbers with a format that doesn't take up too much space. Okay, another data type is text. We saw before that we had passed some text to a print function, and we use double quotes. But strings are pretty flexible. Strings of text, you can use any of these. You can use single quotes around them, you can use double quotes, you can use triple single quotes, and you can use triple double quotes. The single quotes and the double quotes really act the same. The reason you'd use a single quote on the outside is if you wanted to put double quotes on the inside of the string. So it knows that the end of the string isn't reached until it gets to a single quote. So that way you can put double quotes in there. Similarly, in a string quoted with double quotes, you can put in single quotes. And that was like the one we had before. We had an apostrophe in there, which would have been identified as a single quote if we'd had the string in single quotes. Now, you can also put triple single quotes, and the advantage of that is that in the string you can embed line feeds and single and double quotes. You can see here the start of the string is on this line and the end of the string is on the next line. And the same thing works with triple double quotes. So let's have a look at what these strings, so we've stored them in the variables S1, S2, S3, S4, and when we've printed them out, that's what they look like. So you'll see this S3 has an embedded carriage return, but it's also got these embedded spaces here, and that's why it the word line feeds is now has so many spaces in front of it, even though when we wrote it, it was aligned directly under the A. So if you want the L to be directly under the A, you have to do what we've done in S4 and started it at the very beginning of the following line. The last thing we did here was work out what data type it is, and this is what Python calls it, an str, which is short for string of text. Now you can put some special characters into the string, even if you haven't used triple quotes, for example. You can put a new line in with \n, carriage return with \r. You could put a single quote in even if you've got double single quotes as the string quotation mark by doing a / single quote. And if you do want to do a / in a string, you'll have to do double \. So that's pretty similar to other languages. They'll do that as well. So Java has the same escape characters. So let's have a look. If we print out these strings, I'm going to put them all in one print function. Here it's just separated by commas. And when you put separated by commas, it just prints each value and a space in between them. So it prints a 1, the 1, then SC1, special character 1, which is a new line. So you can see it's dropped down to a line. Then it's comma, so it's printed a space. Then it's done a 2. We can't see the 2 there, but this next special character is a carriage return, which what means it's taken it back to the beginning of that line to start displaying the next character, which is another space, and then the 3, and that's why we can't see a 2 there. We can see the single quote, then a 4, double quote, a 5, and then a single \. So is this making sense? Anyone got any questions about this? All right, now one thing that's different about Python strings to other languages is you can put these prefixes in front of the string to give it more information about the string. So for example, if you want to say your string is a Unicode string, you put a U out in front. Now by default in Python 3, all strings are Unicode strings. But if you're using Python 2, you would have to have put a U out in front. And this is probably one of the major reasons for switching from Python 2 to Python 3, is so you can start using Unicode strings quite a lot easier. So the opposite of a Unicode string is a byte string, and that's what Python 2 had by default. And so in Python 3, you would have to put a B out in front of the string if you wanted to say this is a byte string. So a byte string is just 8 bits per character, so a much smaller character set than Unicode. Now these next two are very useful strings. An R string is a raw string, and in which case a / is just like a \, so it will just show. So you can see I've written these characters, and as I've written them, they would in other languages, in normal strings, they would show new line, carriage return, tab, \. But let's have a look at what this looks like. The third one here, raw string, \ is just a \, so we get \, \n, \r, \t, double \, single quote, \, double quote. And the last one is the format string, and I've actually done a couple of format strings already, but what they do is by putting an F out the front here, anytime the string meets these curly braces, it looks for an expression in there and it evaluates that expression. So here it evaluated A as the number 3, evaluated B as the number 4.5, and evaluated A plus B as 7.5. Now these format strings are incredibly useful, but as I wouldn't try to learn every feature of a format string straight off because you'll just get overwhelmed. But just gradually introduce them into your work. So this is evaluating expressions, and next later we'll learn on how to actually format the values in the format string. Okay, so we've had a look at a couple of operations, mathematical operators we can use, and there's some that are integer operators and some that are floating point, and they work differently with different data types basically. So let's have a look at some of the things we can do with integer operators. We use the plus, the dash, the asterisk, the double slash, %, and the double asterisk, and see what they do. So you see plus is addition, so 27 plus 5 is 32. Dash is subtraction, so 27 minus 5 is 22. Asterisk is multiplication, 27 times 5 is 135. Double slash is integer division or floor division, so it'll divide this by that and return the value. So 27 divided by 5 is 5 remainder 2. So we use double slash to get the 5, and % will give us the remainder, which is 2. So that's how we get 5 remainder 2. And the last one, double asterisk, is power. And so 27 to the power 5 is this large number, 14 million, etc. So, and you'll notice that they're all integers. There's no decimal point in any of those. So these are just integer operators. They take integers, they return integers. Now, if either of those numbers was a floating point number, then these operators would become floating point numbers. So let's change A to be 27.0 and run the same things again. And this time we'll also have the single slash in there. And you can see that the results of each one of these has got a decimal point, and if there's nothing after the decimal point, it just puts a 0 in there. So just to be clear that they're floating point numbers that we're getting out, not integers. So once again, addition, subtraction, multiplication, and now single slash is just division. That gives us 5.4 as a floating point result. We can also do 27 / 5, and that'll do whole number division, but it's a whole number, but it's still a data type of float, not of integer. And similarly the modulo works, and power works the same. Alright, challenge 3, so have a go at this, maybe pause the video if you want. Store in variable C the number 123,456,789, and then display double the value of C. Okay, so to store a value into a variable, we say the name of the variable and then an equal sign, and then we put in the number that we want to save, so that's an integer, and we want to display double that value. So we can say C plus C, or we could have done 2 times C. Okay, and the results come out 2, 4, 6, 9, 1, 3, 5, 7, 8. That's a pretty easy challenge. Hope you managed to do that one. So let's have a look at the solution. And I like to, even in these absolute beginner sessions, I like to throw in a bit of code that people may, even the more advanced people, may not have seen before. And so what I'm showing you here is that when you're typing in an integer or even a floating point number and storing it in a variable, it can sometimes be hard to read what that number is. So you can put underscores in the number to separate it out in thousands, and I mean, you can do other numbers as 10,000s if you want, but in Australia we would always do thousands. You can't put commas. Commas separate numbers into different things, so that's a shame we can't use the comma for separating the thousands, but the underscore is effective in what it can do. So it says C equals that, and then double C is C plus C, and it gives us the same result. So you can see that putting in C with underscores and putting in C without underscores is exactly the same effect. It was just a bit easier to read the one with underscores. And when we displayed the result, it didn't have underscores. The next line here shows us that our F strings, our format strings, can evaluate expressions. This is how we actually put in curly braces. If we want to put them in the display, we have to actually do a double curly brace, and then this one got evaluated with the number showing out but without the thousand separated. Now it is possible when you're displaying the results, you can separate them by in the thousands. So in the curly braces, if you put a colon, everything to the left of the colon is the value to be displayed, and everything to the right is the format that you want to use. So in this case we want to use the format of underscore, and that will automatically separate the thousands out using underscores. So that'll look similar to how we started. Still not really what we're used to, but we can use a format of commas, and this will display it like that, with commas separating the thousands. You can even do things like, say, I want it to have a maximum number of characters of 17 or a minimum number of characters of 17. I want to separate the thousands by commas. I want to show a decimal point, and I want to show 3 places after the decimal point, and this is all based on a floating point number. And so you can see it's been padded out to 17 characters. If you count that, that'll be 17 characters. I've got 3 characters after the decimal point, and I've got my number separated into thousands with commas. So these F strings are a pretty powerful way of formatting numbers. Okay, challenge 4. Find the remainder after an integer dividing an odd number by 2, and then try an even number. Okay, so let's try the remainder of what was the first one? An odd number. So 11 remainder after dividing by 2, and we'll do an even number. 2, 3, 2, 2. So the remainder of an integer after dividing it by 2 is 1, and an even number is 0. So we've now got, and let's have a look at the solution here. The solution's done a loop here of several numbers. So we're not going to get much into loops today, but this is how you do a for loop for I in range 5. So it'll do 0, 1, 2, 3, 4, up to but not including 5. And then everything you want looped, you use this indentation to tell Python where the loop is. So other languages use curly braces to enclose the code block that's going to be looped. In this case, in Python we use indentation, and that will keep loop all those lines of code that are indented by that much in the loop until the next line of code is not indented, and that's how Python knows the loop has ended. Alright, so we've got 0 modulo 2 is 0, 1 modulo 2 is 1, 2 modulo 2 is 0, 3 modulo 2 is 1, 4 modulo 2 is 0. So you can see we're just flipping backwards and forwards, 0, 1, 0, 1, 0, 1. And all of the even numbers come up with a 0, and all the odd numbers come up with a 1. So we've got a good way of identifying odd and even numbers. We've also got a good way of creating a sequence that goes 0, 1, 0, 1, 0, 1, alternating backwards and forwards. Okay, this is a bit of an advanced section, so absolute beginners just ignore this. But there are some other operators, like this vertical pipe symbol, the ampersand, circumflex, double less than, double greater than, and they're what they call the bitwise operators. So they convert the numbers into bits from bytes, and do the operators on them, do the operations on them that way. So for example, A is 10, and 10 pipe 3 returns 11. And so if you want to see how that works, 10 in bits is 1010, 3 in bits is 0011, and that is like an OR symbol. So if it's it counts the same all through the digits, and if either of them is a 1, then the result is a 1. So the answer is 1011, and that translates back into decimal as 11. Similarly, 10 ampersand 3 is 10 and 3. That returns a 2. We've got the same two input numbers, but yeah, the result only has a 1 if both of them have a 1. So the third digit is the only one that's got a 1 in both of the input numbers. So our answer is 0010, which translates back to 2 in decimal. And you can look at these formats that I've used to show all this. I've used 0 padding. The greater than sign says I want it right aligned, so you can right align or left align. The B says I want it shown in binary, and the 4 says I want it to be 4 characters wide. All right, you can work through the rest of those. If you understand the first one, then you've probably got a chance of working through the rest yourself. If you don't understand the first one, well then no matter how much I talk about it, it's not going to help. All right, string operators. So we've used these operators on numbers. Let's have a look on text. You can use 2 operators. You can use the plus and the asterisk, and they work a bit like multiplication. So well times 3 plus 3 holes in the ground will give us well. So that's that string multiplied 3 times and then added to this string to give us this total string. In Python, adjacent strings don't even need the plus, and they can even use different quotation marks. So you can see here I've put 3 strings with just a space between each one, and they get joined all up into one string, and whatever you do with it, you can store it in a variable or print it out, whatever you want to do. Okay, interesting side effects. Integers can have more significant digits than floats. Remember, floats have about 17 significant digits. So if I said, what am I doing with E? Not much. Don't really need E. But if I've got 25 divided by 7 is going to print it out using floating point numbers or floats, and you can see I've got about 17 significant digits. But if I take big integers without any decimal point in there and integer division with 7, I get the same digits here, and I can get a lot more significant digits in my answer. So if you wanted to say calculate pi to 1,000 decimal places, you could do that with integers. All right, the next thing, floats. You have to be aware that they can't store decimal numbers exactly. This is fine for science, but not good for accounting. So let's have a look. Let's add 1.1 to 2.2, and we don't get 3.3, we get 3.30000 all the way up to 3. And the reason for that is because they don't convert exactly into a binary number. 1.1 is there's no binary number that exactly represents that value, and same with 2.2. So you're going to have these rounding errors when they get displayed. I mean, Python does a good job, a pretty good job. Like the 1.1 is actually not exactly 1.1, but it goes, well, I know that's what you meant because that's what you wrote here. Well, not because that's what you wrote here, but because it works it out because it is equivalent to 1.1000 for the number of significant digits that Python would normally display. And so it goes, well, I'm not going to just put all the zeros there. I'm assuming you're going to mean 1.1. But 3.3 was too far different, and so it does get displayed with all those zeros and the 3. Okay, challenge 5. Let's have a go at some more. So integer quotient and remainder when dividing 66666 by 235. So we'll do an integer division. And I can do two things on the one line here, just separate them by commas. And find the modulo. And so it's 2836 for the first answer and 206 for the second as the remainder. So we would expect that to be less than 235, and it was. Calculate 2 to the power 10. So remember the operator for power is double asterisk. Find the decimal quotient of 6666 divided by 235. So you just use the single divided by sign for that. And you can see 2836, it's got the same number to the left of the decimal point, and 0.876 is going to be about 206 divided by 235. Store in a variable the name of your favorite programming language as a string. So let's have a variable called S5 equals Python, and construct a new string that starts with programming in and finish with is fun. Okay, so I'll have programming in, that's one string, then we'll put in our variable S5, and the resulting string, programming in Python is fun. Okay, let's have a look at some of these solutions. Most of them are pretty similar, although it's used format strings for showing all the results. We've used C1 as a string with Python in, same as S5, and we even used a format string to create the new string. So that's a good way of doing it. And then we've used a print statement to print out the results. Alright, let's look at another data type, boolean. Boolean data types store true or false, and that's the result of any of the conditional operators. So we can run, they're like running tests and see whether something is true or false. True and false are actually keywords, and they have to have a capital letter, unlike other languages like Java or C where they're lowercase letters. So let's have, they're actually keywords, true and false, and they're both of type bool. So we can use the double equals sign to see if two values are equal. Remember, if we use the single equals sign, that's used for assignment if we want to assign a value to a variable. But the double equals is if we want to compare two values and see if they're equal. And in this case, 3 is equal to 5 minus 2, so the result is true. Can we check if 45 is greater than 23? And the answer is true. minus 10 is less than minus 20. The answer there is false. And C1 equals Python, and that is true. Alright, so challenge 6 here. We've got a bunch of different expressions, and you've got to predict what the answer is going to be. So C1 equals to Python. So there we did C1 equals Python with a capital P, and the answer to that was true. So let's try that with a lowercase p, and that returns false. And that's because strings are case sensitive in Python, and when you're comparing them they have to have exactly the same case. What's this operator here is exclamation mark followed by an equal sign is the not equals operator in Python. So C1 does not equal Python with a lowercase p, returns true. You'd expect that to be the opposite of equals equals. Okay, 253 is greater than or equal to 1518 divided by 6. I can't remember what 1518 divided by 6 is. But yep, 253 is greater than or equal to it. Let's check less than or equal. And this 1518 divided by 6 is actually 253. So both greater than and equal and less than or equal both return true because they're both equal. And the other interesting thing about this is we're comparing an integer to a floating point number, and but it's the operators still work. All right, now let's have a look at the some irrational numbers that have got approximations stored in one of the libraries. We've got a math library, which is a standard library. So to use it, all we have to do is say import math, and then we can use E, which is the base for natural logarithms. We use pi, which is the ratio of a circle circumference to its diameter. And we're going to check, is E less than pi? And it is 2.718, that's E, and pi is 3.14159. So that returns true. Okay, tau is equal to the ratio of the circumference of a circle to its radius, which is actually the same as 2 times pi. So in this case we're going to check, is E less than 2 times pi and less than, which is also less than 2 times pi. So you can put several of these operators in a string like this and it checks that they all have to be true. But in this case 6.28 is not less than 6.28 because they're equal, and so the whole expression returns false. Okay, so I've got a question here. What is your advice to learn all the initial tools for beginners? So by tools I assume you're meaning ways of working with the language, and so my advice for that is going to be learn with these interactive Python tools. So that's why I use Google Collab. Once you've got your head around this and written some short programs, and you'll see in our series of Python we will use Google Collab quite a lot, but then occasionally I'll use PyCharm and show you how to do it in a proper integrated development environment. And if you're starting to write long programs, that's when you start to use these integrated development environments. Okay, so for the literacy, so I think one of the things that if you want to understand what each of these things are, then use the built-in help, it's very useful. So for example, I showed you how to do a question mark before. I could do question mark print, and that'll tell me over here on the right, it tells me what how that works. I don't know if that helps you as a beginner. If you read something like that, does that make sense? But at least it might give you a starting point. I find doing programming is the best way to learn programming. So give yourself some small challenges and try to solve them yourself. So this question mark, that works in IPython. If you want to do the same thing in just straight Python, use the help function, and that will give you the same results. If you want to see what some of the keywords do, so see what import does, and that's not going to work because it's a keyword, but we'll stick it in a string. Yeah, I don't know that that's very clear. Oh yes, it is. Here it is, the import statement. Find a module, loading and initializing it if necessary. That's what the import does. So you can use that on your standard libraries. Alright, but asking questions is also a good way of learning. So feel free to ask any questions about any particular commands, and we'll do our best to explain them to you. I'm trying to break this one down. There's a lot of stuff that we're doing at once here, and so I think you need to have a bit of a break where you're doing some coding and then doing some reading or learning. And so by doing this one at a time, hopefully I'm not overwhelming you, but maybe I'm going too quickly, so let me know if I'm going too quickly. All right, we're going to check here on strings, and we're comparing strings with these less than and greater than operators. A is less than C, and that's going to return true, and it returns on that is a way of checking if something's in alphabetical order. We can use less than and greater than. It only works if they're the same case though. Lowercase a compared to uppercase C returns false for less than, because uppercase characters always appear before lowercase in Unicode. So just a couple more examples of that. Okay, and here's a useful one. If you want to see if one string is inside another one, you can say one string in the other, and it has to be exactly in it. So let's have a look at the results for that. AT is in catch, as you can see there. AC, both the letters A and C are in catch, but they're not next to each other, so that returns false. TA, they are next to each other, but they're in the wrong order, so that also returns a false. We're getting close to the end of these. True or false returns true. So here we're looking at the keyword or and what that does. Look at the keyword and. True and false needs both of them to be true to be true. True or false just needs either of them to be true. And the one that always confuses me is true or false and false, and that's because and has precedence over or, so those are evaluated first, false and false, which is false, and then that is compared to true or false, and that's going to be a false. True, sorry, because there's one true in there. And I think just work through these yourself. I'm not going to make it any clearer by talking about this. And there's one more here. Is you normally only do that for beginners. You'd only do it if you want to compare to none. So for example, you want to see is the variable a is none, you'd use the is operator. And C1 is C2 because they both refer to the same place. And so that's what is does is it works out if your two variables are referring to the same location in memory. Okay. Bixby's asked, how do you use F strings? And that's a really good question. So let's create a couple more code cells here. So if I've got a string, my string, and it just displays straight as a string. Now I can put into here an expression. So let's put in an expression, say a, and I'll just expand this a bit. Now this is just a normal string, so I haven't. It just displays the exact values that got typed into it. Now if I convert this into an F string, all I've got to do is put an F before the double quotes, or before the quotes for the string, and that could be triple double quotes, or triple single quotes, or just single quotes. It changes these curly braces into now saying evaluate that expression. And you can see even in Google Collab has recognized this F string and changed the color of this part of the string to say I'm not going to give you those characters verbatim, I'm going to evaluate the expression. And so when it evaluates it, it now says the value of A is 10. So I'm using it. That's how you use F strings. You can use them in print statements. You can use them storing the value into a new string. So I could say S6 equals that F string, and then print S6. And now S6 will always have that value, so I can do S6 again, and it's still got the value. Now, and you could put lots of different curly braces in there evaluating lots of different expressions. I'll just stay with the one. Now you can format it. So I showed you some formats before. If you're going to do a format, then you put a colon in there and say we want it to be right justified 10 character, we'll go 5 characters wide. And I might need to put in, oh yep, that's done it. So it's padded it out by 5 characters. Now I can say these are the sort of things you can do with F strings. You can pad with a different character. Say I want to pad with equal signs. And so it's made it 5 characters wide by putting in 3 equal signs in there. I can say I want to show 1 decimal point. And if you do that, you really have to say it's a floating point number, even though it was an integer. So it converts it to a floating point number, puts in 1 decimal place, and pads it with an equal sign. So that's all I'll tell you about F strings for now. Have a look up the documentation on the Python site, and they'll give you all the things that you want to do if you've got a specific case that you need to solve. Alright, how are we going? Alright, so one more data type we'll look at tonight will be the list. And the list enables us to store lots of different other data types in that one data type. So create a list by using these square brackets. And let's just create a list and print it. So there it is. You can see I created them with double quotes, it's printed them with single quotes. It doesn't matter, all strings are the same once they've been created. It doesn't matter, it doesn't remember how you created it, it just saves it in a particular way. So we can refer to individual items within that list by an index, and you put the index in square brackets after the list name. And one trap to avoid is don't ever call your list list, because if you do that, you'll overwrite the built-in function that actually creates lists, and so it'll make it more difficult for you to create lists in the future if you've got a variable called list. So I just call it lst because I know that that's a different one. So 0 index is 6, 1 index is 5, and 6 gives me 0. Now a clever thing that you can do with Python lists is that you can count the index back from the end. So if I want to know what the last one is, I say what's the item with index -1, and it'll count back 1 from the end and gives me 0. So remember, 0 is here is the last one, so -1 gives me the last one, -2 gives me the second last one, which is 1. Find the length of the list, use this built-in function len, and it's 7. Now we can slice the list up and just get several values from it by using this notation here, 2 numbers separated by a colon. So 2 to 5 will start at index 2 and go up to but not including 5. And some people get confused with the why it goes up to but doesn't include the final value, and the way I remember it is I think of the indexes as counting positions between the elements rather than the elements themselves. So you can see on the I start 0 at the left hand end, and on every comma I put a number, so 0, 1, comma 2, comma 3, comma 4, comma 5, comma 6. And so if I wanted to slice from 2 to 5, I want all the values that go from 2 to 5, and you can see that that's them, 4, 3, 2. And similarly, you can use negative indexes on all of them, and they'd work the same way. So you could do from index -5 to index -2 would give you 4, 3, 2 as well. If you're starting right from the beginning, you can leave the 0 out. It'll just assume it's from the beginning. And if you're going all the way up to the end, you can leave the last value out and say, and in fact that's the only way to do all the way to the end. At the beginning you could put 0 in, but you can't really put -1 in there because it would take you up to there and you'd miss the last element. I should run these so you can see the results. Up to but not including 4, from 3 to the end. Now the other advantage of doing the up to but not including is that if you want to know how many it's going to return, it's going to be the second number minus the first. So 5 minus 2, you're going to get 3 elements get returned. Now you can put 2 colons in, and so that the numbers between the colons, you'll have your starting number, starting index, your ending index, and your stepping index. So, and you can leave these ones blank if you need to. So we're going to start from 1, go up to the end, and go up in 2s, and so that gives us 5, 3, 1. Lots of things you can do. You can even do clever things like this, starting from the last one and counting backwards, but not including index 1, stepping in -1s. 0, 1, 2, 3, 4. So that's reversed the order because we've put a negative step in there. You can change values in the list just by referring to, I want the value at index 2 to now be 4. And now if we look at the list, rather than the digits, the number, floating point number 4.0, we've now got the letters FOUR. And similarly, we can do it to the last one. We'll change that to a blast off. You can delete an element from a list. So I'll just go through these because you're not going to remember it until you actually need it. So that's everything you do with lists. You can do strings can also use slicing. So square brackets and then some numbers. And you see where you can extract a part of the string going from 3 to 7. Now a string is immutable. You can't change it once it's a string, so you can't do things like delete a character out of it or assign a different character to one of the characters, but all the other string slicing operations you can. Alright, now we'll just one last thing is to cover the what we do if we are really worried about the floating point rounding errors that we occurred before because of our converting decimal numbers to binary. And Python provides us with this decimal class. So to use decimal class, we've imported decimal here as the library. And inside that is the class. So the classes start with a capital letter. The library, well, in this case it starts with lowercase. And then we give it the numbers that we want. So remember 1.1 plus 2.2 using floating point numbers gave us 3.3. So now if we calculated it using decimals, and I've got to remember to run the cell first. I've got to import it and then I can create it. The answer is decimal 3.3. Now this is a pretty long-winded way of working with decimal numbers. You've got to do decimal dot decimal every time you wanted to do it. So there's another form of using this import command where you can just import the class that you want and then you don't have to qualify it every time you want to use it. So, and that's using from. So we can say from decimal import decimal. And then we don't have to type decimal dot decimal, we can just type decimal with a capital D. And that gives us the same answer. And you can even use aliases using the as keyword here. And we could alias it just as D, and so that makes it even more manageable. Now one thing I should mention when you're using this decimal class is always pass the numbers to it as a string. If you try passing it as a floating point number, you've already done the binary conversion, so you've incurred the floating point error. So you can see if I did D 1.1, it's going to come up with this. That's what happens when you convert the binary back to a decimal number. But if I put that in quotes, the decimal class knows how to handle that without it getting converted to a binary first, and we'll treat it exactly as 1.1. Alright. Now these aliases here, I thought I'd mention these two. A lot of people who come to these Python sessions are interested in data science, and two of the most common libraries that you use, these are third-party libraries, are Pandas and NumPy. And just about everyone who uses them, when they import them with these aliases, so they don't have to type pandas dot every time. They can just type pd, and they don't have to type numpy dot something. They can just type np. Okay, so that's the end of the session for tonight. We've covered these keywords. So the number we've covered, I've used a list here. Find the length of the list is 14. So we covered 14 of the 35 keywords, so we've done a fair bit of Python in just one session. But obviously we've picked the easy ones, and there's a lot more with each one of those that we've done. Next week will be a more advanced session. We'll be looking at how to web scrape HTML pages, and also how to parse XML files. So we'll be using the beautiful soup library to do that. And so that's to do with collecting data. If you're interested in how to collect data from different places and how to manage that data, then come along next week. Even if you're an absolute beginner, we still like to have absolute beginner questions on the more advanced sessions, because we really are trying to provide an entry point for beginners to get into Python. And really, it's the starting point of getting into Python is the hard bit. So I hope you've enjoyed the session tonight. You can continue to ask questions on Slack. I don't think you can ask any more questions on the YouTube chat, because that'll lock up once I stop the recording session. So next week is XML files, HTML, web scraping, and the week after that, Arun will return with some machine learning. Thank you.